Hello everyone, my name is Subhash. I am currently pursuing a Bachelor of Engineering in Dayananda Sagar College of Engineering. I'm currently in 8th semester right now from Telecommunication department. I'll be explaining technical part of our project. Let me share my screen first. This is the title of our project, developing a system for paralyzed people using brain-computer interface and machine learning. Our team ID is 1522463 and the team name is BrainFormatica. We are from Dayananda Sagar College of Engineering, Bangalore, Karnataka. We are studying in Department of Telecommunication Engineering. These are our team members, and we are doing this project under the guidance of Mr. Santhosh B, Assistant Professor, Department of Telecommunication Engineering. These are the table of contents. I'll walk through all these concepts one by one. First, let me begin with the introduction. Let's see let me begin with what is brain-computer interface. It is an explicit connection between mind and machine. BCIs have emerged as a great approach to treatment of neurological disorder. It has different types for different users. The main function of BCI is to collect the information from the brain through electrical signals via neurons, and then these signals can further be processed using external devices as well. And this device has the best application for the paralyzed patient. Since no physical work is required, this device can also be used for the people who are lazy to do physical work as well. In the new researchers, it is found that this technology will grow in applicability to medical field. Now let's see the problem statement. The basic problem of a paralyzed person is the communication of his or her needs to the caretaker. In this study, in this project, we came up with a solution with using brain computer interface. A brain computer interface can be considered as the solution and can also be a convenient way for the patients who cannot convey even the fundamental needs such as water, food, washroom emergency, etc. Using this BCI device, the patient can communicate accurately and adequately. This device doesn't need any physical movements to interact with it. It can be determined using brain activities based on EEG signals. In this project, we are focusing on developing a practical BCI system to enable binary communication of patients using machine learning. Now let's see what are the existing technologies we have. The first one is called NeuroSky. It is a device developed by NeuroSky Technology. They started working on this device. They showcase this device in Nekomemi, an inspired feline ear built in on a mindwave band set. The brain can be designed to optimize health, education, alertness, and overall functioning. Then the next device, existing device, is OCD technology. Uh, be it a gamepad, a joystick, mouse, neural impulse actuator is used to detect three types of signals generated by our brain, facial muscles and muscles of eye through a particular headband as well. And the next device which we have is speech generating devices. The famous Stephen Hawking and the late Roger Ebert have used this device. This is necessary for people who have slight means of cooperating vocally. Now let's see the proposed system of our project. The main core technical innovation of a project is in the present days, people are suffering with a lot of health problems. A normal person can express their feelings by saying it, but the deaf and dumb humans, those who are already suffering from paralysis, cannot say what they need because their motor nerves are affected, right? So, to overcome this problem and to help paralyzed people with the help of BCA system, we come to notice what they must be feeling and what they need. And the uniqueness of a project is many of the projects which are developed or related to BCR between a normal person and performing some experiments on the specimen, they have got the output. But in our project, with the help of the same device, rely on this same range of frequencies that we get, we determine what that person requires can be sent to that caretaker. Basically, we can determine the communication between the paralyzed patient and to the caretaker. And the objective of a project is the main intention of a proposed project is with the help of BCI between a paralyzed person and device, and sends the received information in the form of message to the caretaker. Now let's see the methodology of a project. This is the block diagram of our project, showing a flow of our project. Uh, at first, the recording of brain's electrical pulses for a certain period of time we take it from EEG signals. It is called EEG signal, electroencephalogram. Uh, as I said, initially the brain signals are fetched from the brain through electroencephalography, and the measurement of these EEG signals are very difficult because these EEG signals have very small amplitude waves in microvolts. The position of electrovolts also be crucial in this stage. The electroencephalography signals are digitalized and sent it to the major important stage of the BCI system, and it's called digital processing stage. And it has two major blocks called feature extraction and translation algorithm. In feature extraction, these algorithms are in accordance with frequency analysis and high order statistics, also in relevance with wavelet transform and autoaggressive model. These works on voluntarily selected sections of signal, and in the translation algorithm, it takes the abstract feature vectors from EG signals which reflect the specific aspects which encodes the message a user wants for communication, and transform these vectors into implementation device command. The target of the translation algorithm is to maximize the performance of the application. In this Bluetooth package, the signal is transmitted to the outermost receiver, or through the external receiver. The caretaker of the paralyzed person can communicate or understand what the person is trying to tell easily through GSM transmission of a speaker. Uh, in digital signal processing system, there are basically main three elements called data conditioning and digitalization, digital filtering of band pass signals, spatial power computation. These are all we do it in the digital signal processing system. This filtering process is done to extract the signal power lying between the frequency range. For example, let's say 7 to 12 hertz. This represents alpha band of EEG. There are many approaches for this job. Let's say band pass analog filter is used to filter the EEG signals before digitalization and subsequent power calculations as well. The digitized EEG data is fast, Fourier transformed, and pick the spectral power line within the alpha band. The signal length for each segment is 10,000 to 17,000 data points per channel of EEG depending on the data range. And since this is not desired, so the spectral computation post digitized EEG data is performed based on the digital band pass filtering. This is the highly preferred approach compared to other approaches. There are many steps involved in this. First, we do pre-recorded two-channel EEG data, and then we do preconditioning of amplitude and bias, and then analog to digital conversion and sample storage, and then we'll pass into bandpass filtering of sample data. Then we'll be doing power spectral computation of alpha band. Then we'll get the factor analysis of our project. These are the basic steps involved in digital signal processing of EEG signals. Now let's see how this system or our project helps paralyzed patients. In this analysis, we focus on condition called totally locked in state, which can be termed as a CLSI. They are basically called paralyzed patients. In this circumstance, intentional perceptions can infrequently be acted or physically, as many doctors believe that the peculiarity of life in paralysis is extremely low, and to continue to live their life is a burden for that patient. So in this research, we have found out a solution for that particular problem. A brain computer interface can be used by paralyzed patients, which help to convey with an electronic device for their daily needs, such as if a person is feeling hungry, or if they need to go to the washroom, or if they want to express their feelings with their caretakers, or if they want to switch on or off lights, etc. All these basic things can be accomplished using a brain computer interface, which can be detected using EEG signals from the brain, and which will predict the outcome in conformity with the threshold frequency. By this, paralysis people can able to express their intentional thoughts. We pass this EEG data into a machine learning algorithm called support vector machine model. In that model, first we do the splitting of the data set, which we get from the brain signals recorded through a brain computer interface. We do the splitting of the data set into training data and testing data. Then we train the model, support vector machine model, using this training data, and then test the model to get the prediction of how that person reacts to that particular question or particular situation. Now let's see the outcomes what we have got for this project. Here we are seeing the command line interface of Windows PowerShell, where we ran the model of our project, where we get the valence and arousal feeling. It means that if in valence we'll get to know that the positive valence or negative valence of an event, object, or situation. Uh, and arousal means it's an intensity level of autonomic activation that an event creates, and ranges from calm to excited. It means that ranges from low to high. By this we can get to know how that person is feeling by getting this data. Let's say that if a, if you ask a question to the paralyzed person, do you feel going to washroom, or do you want to switch on the light, or are you feeling hungry? And by this valence and arousal predicted data, we'll get to know that how that person is feeling. If you're getting a positive valence, means that person is feeling positive feeling on that particular question. Let's say if a person is feeling angry, means it will show the positive valence. If a person is not feeling angry, means it will show the negative valence. Similarly, the intensity as well, it means the arousal. We got pretty good accuracy for both these conditions as well. We got about 98% and around 97.8. It means 98% for both valence and arousal condition. uh, we got pretty good accuracy, and the model is working perfectly fine. And due to we didn't get the real brain computer interface uh, model to do the real analysis, so we took the data from Google. We took the brain activity from the Google, and we did the analysis. We did the pre-processing stage, and we have created built a model to get this analysis as well. Now let's move to the conclusion part. The biggest impact of BCI on paralyzed person is that the BCI reads the brain's blood oxygen stage, and permits communicating by decoding the intention of a person who are totally paralyzed and incapable of talking. So this BCI works on electroencephalography, as I already said, which measures the electrical activity on different parts of brain of a human being, and visual or traces on oscilloscope screen. This technology is very much useful for the paralysis people, because this is a system which permits human to interact as normal person. Mind machine interface is developing more features day by day. More inventions are coming up in brain computer interface. Since this device is going to be a digital solution for paralyzed people, so that they can communicate with the caretaker, so that they can have a feeling of a normal person, so that they can communicate all the basic needs to the caretaker. This device is going to help a lot for their daily basic needs. So it is very useful in all the real world applications as well. This is the publication we have done. We have published a research technical paper called Faster Communication Considering Emotional Quotient Using Brain Computer Interface in an international journal called Perspectives in Communication, Embedded Systems and Signal Processing, called PISIS Journal. It is an international journal and Google Scholar Index. And this paper is also got indexed in German National Library. There our paper has selected on this project, and has been indexed in German National Library as well. Thank you.